This is 5.6 day 2, continuation of the quadratic formula. Today we're going to focus on finding the discriminant and complex zeros. This formula is already in your notes on 5.6 day 1, working with quadratic formulas. So I just want to review with you. Here is your quadratic formula. What the quadratic formula does is it helps you to identify the zeros of the equation or function. There is a chart on this slide. I'd say you might want to write this down. B squared minus 4ac is called the discriminant in the quadratic formula. If I go back to this slide, this b squared minus 4ac falls underneath the radical, which is the radicand. There's three different scenarios. If you get a positive discriminant, so let's say when you reduce it down and your radical is a positive number, you'd have two real solutions or two x-intercepts on your graph. The next one in the box says if you have a 0 as your discriminant, then you'd have one real solution and one x-intercept. If you get a negative underneath the radical, which means it's an imaginary number, it's a complex 0, so it has 0 real solutions and 0 x-intercepts. So I have three different graphs. You don't need to draw these graphs on your paper. So here would be the first example where your parabola opens up and you have an x-intercept right here and right here. That's the scenario when you have your discriminant in your quadratic formula, and let's say you have a positive 5 left. Then you'd have x-intercepts of plus or minus. The next scenario is when your discriminant equals 0. So what happens is this term cancels out. So you'd have only one x-intercept. The last scenario is when you have a negative radical. Let's say negative 6 plus or minus. What happens is those parabolas are above the x-axis. So let's go on to our first example. This is what I would recommend you write down. Find the discriminant and identify how many solutions there are. How many real solutions. So we have a quadratic equation, 2x squared plus 4x plus 1 equals 0. And we want to identify the discriminant. We're not asking you to go out and find what the zeros are at this point. So we identify the a, which is the leading coefficient of the x squared term. Identify the b, which is the coefficient of the x term. And then the constant, which is 1. Remember, this a, b, and c is what we used in the quadratic formula. But we're just focusing on the radical, the radicand of b squared minus 4ac. So we say b squared minus 4ac. And then we reduce that down. So we get 16 minus, and then negative 4 times 2 is negative 8, times 1 is negative 8. Then 16 minus 8 is 8. This is a positive 8. So if I go back to this chart on the previous slide, we had a positive discriminant. So that means we have two real solutions. So we have two x-intercepts. So it asks us to identify the discriminant. So you'd say your discriminant equals plus plus 8 or positive 8, and you have 2 real solutions, which are 2 x-intercepts on my graph. Here's a second example. Find the discriminant and identify how many solutions there are. Then use the quadratic formula to find that solution. So we're going to go one step further than that last example. So our equation is 4x squared minus 4x plus 7 equals 0. So our a value is 4, our b value is negative 4, and our c value is 7. Now we plug it into the discriminant equation. Negative 4 squared minus 4ac. And we reduce that. Negative 4 times negative 4 is positive 16. And then negative 4 times positive 4 is negative 16, times positive 7 is negative 112. And what we get is negative 96. This is our discriminant. So now let's go back to our chart. Our discriminant is a negative value. So that means we have 0 real solutions. We have what we call a complex solution, and we have 0 x-intercepts. So it would be either above or below the x-axis. So after identifying the discriminant, we identify how many solutions there are. So there are 0 real solutions. And in this question, it asks us to go out and find the solutions using the quadratic formula. So we're going to use the quadratic formula. We've already identified our a, b, and c. So it's negative b plus or minus. And now remember that b squared minus 4ac, we just found up here as negative 96. So I can just replace that right now as negative 96. We've done the work for it. And then all over 2a, and our a value was 4. Now let's reduce. So negative negative turns it to a positive 4. And then 96, remember, when you have a negative, you have to replace it with an I because it's imaginary. You can't leave a negative underneath the radical. And then all over 8. And those are your 2 real solutions, or imaginary solutions, which we call complex solutions, or complex zeros. These will not be x-intercepts on our graph. Here is a second example that you can just watch. We're going to use the quadratic formula to find the zeros of the function. So we identify our a, our b, and our c. We plug it into the quadratic formula. So x equals negative b plus or minus b squared minus 4ac all over 2a. And now we reduce. 3 times 3 is 9. Negative 4 times positive 4 is negative 16 times negative, or positive 2 is negative 32, all over 8. Now we reduce the radical. Negative 23 over 8. What comes up again is a negative radical. So we have to remove that negative and replace it with an I out in front. I have a negative discriminant. Remember, this is my discriminant. It's a negative, so I have no real solutions. I have no x-intercepts for this parabola. And these are what we call the complex zeros. Here is a continuation of this example. I think we're going to skip it since we just did one that are very similar. Here is the homework on 5.6 day 2, page 361, 14 through 16, and then 8 through 12.